So we've spent a little bit of time reviewing how to deal with fractions, simplifying them, multiplying, dividing, adding, and subtracting. Today we're going to concentrate on simplifying rational expressions. And a rational expression is really just a fraction, but fractions that contain polynomial functions. And in order to reduce fractions, specifically rational expressions, you have to find and take out common factors. Okay, and just a couple quick things I have in highlights here, very bolded, is that in order for us to simplify fractions, we have to be able to cancel, and I use that word in quotes, which really means reduce to one. We have to be able to cancel factors. Okay, so we'll take a look at some examples where you are only dealing with multiplication versus examples like this where you have terms that are added, and so you have a little bit more to do in order to factor. Okay, let's start with example 1, letter A. In this particular case, we have 3 times x to the 5th times y to the 6th divided by 6 times x to the 8th times y to the 3rd. And yesterday during class, and I saw a number of students suggest that you could break this apart, and if you wanted, you could do that. You could consider each piece almost individually, so that way you're dealing with the x's, you're dealing with the y's, and you're dealing with the constants. And then from here you can simplify each of these. So 3 and 6, they have a common factor. 3 goes into itself 1 time, 3 goes into 6 2 times. And then if we look at the x to the 5th over x to the 8th, a number of you were using your exponent rule, so you did x to the 5 minus 8, which would be x to the negative 3. And I might change my instructions to say using only positive exponents. So that means I can't leave it as x to the negative 3. I'd have to use my exponent rules for simplifying. If I have x to a negative power, that's the same as 1 over that power positive. Okay, so that's one of your exponent rules. So in this case, I can say, okay, well, x to the 5th goes into x to the 5th 1 time, and x to the 5th goes into x to the 8th, x to the 3rd, okay? So you can kind of think about it as whatever the power is. So if this is a 6, this is a 3, wherever the power is bigger, that's where you're going to leave it. Okay, so here it was bigger in the denominator, we left x cubed in the denominator. Here, y to the 6th is, the 6th power is in the numerator, so we're going to reduce that to y to the 3rd. And so then our final result is 1 times y cubed over 2 times x cubed times 1. And so we have 2x cubed. Okay. And then I'm going to ask you to either pause the video or after you're done watching the video to go ahead and complete B and C. Okay, let's move down to the next type of simplifying problem. And notice I wrote in bold caps, make sure you factor first, okay? I tell students often UF, UC. So UF, UC. You factor, and then you cancel. And again, I always say cancel kind of in quotes, okay? So the reason I use this is because it looks inappropriate, so people tend to remember it, but it hopefully helps us to remember you have to factor before you can cancel. Okay? All right, so let's take a look at the first example. If I look at the numerator, I'm looking for factors of 14 that add up to 5. Negative 14 that add up to positive 5. So essentially, if you're thinking about A times C or your product, you have negative 14. Your B value or your sum is equal to 5. And we're looking for 2 factors. So we have obviously opposite signs. Positive 7, negative 2 will work in this particular case. Okay, so then we'll make our 2 factors. We have x plus 7 times x minus 2. And then in the denominator, we have the difference of perfect squares. If you remember that rule, then you can go ahead and write down the conjugates or factor it using the conjugates. You could also deal with this by using product sum. So in this case, our product is -4. The sum, or the middle term, is 0. And so that means your two factors are going to be 2 and -2, so that they would add up to 0, multiply to give you 4. So you could always use your AC box or split the middle for even ones that are difference of perfect squares. Okay, once you have everything factored, then you can look for factors that are the same. And so in this case, I have an x minus 2 and an x minus 2. So those would cancel. And again, cancel really means reduce to 1. So then I have my answer, which is x plus 7 over x plus 2. Often I tell students to kind of leave these in parentheses to remind you that they're all one piece and that you can't factor any further. Okay, the second part of the instructions asks us to find the value or values of the variable that make the fraction undefined. Okay, and so I just want to say that it's undefined if undefined at any point in the expression. Okay, so that means for this particular expression that we simplified, we have to consider that it could be undefined when x equals -2, the answer that we just got here, but it could also be undefined if x were 2. So if I had a 2 here, 2 squared is 4, minus 4 would be 0. -2, the quantity squared, would be 4, minus 4 would be 0. So in this case, it's undefined for both 2 and -2. Now you could write that one of two ways. You could say undefined and then say x equals that, or you can say x not equal to positive and -2. So that indicates that those values of x would make the expression undefined. Okay, again, I'm going to ask you to complete B and C. Either pause the video now to complete them or do them at the end of the video. The last example I want to talk about is something that's very, very common. I am almost certain that you'll see an example like this on the Regents. Okay, so the idea is that you have two factors that they look like they're almost the same, but not quite. Okay, so let's take a look at one with numbers, right? Because simplifying fractions or rational expressions is very similar to how we simplified numerical fractions. And so if I were to evaluate this, I have 9 minus 6, which 9 minus 6 would be 3. And then 6 minus 9, which would be -3. Okay, and so if I were to divide these, I would get an answer of -1. Okay, and that's important as we look at examples that look like this. Okay, so now let's consider this. I'm going to rewrite them so that I have a minus b and I have -a plus b. Sometimes it makes it a little easier if you can see them written this way. And now I'm going to consider, okay, these look really similar. The only difference here is that this one would need to be multiplied by a negative. So if I did -1 times this, I would get -a plus b. Or I could factor out a -1 from the denominator. Either way is perfectly fine. Okay, so I'm going to go ahead and simplify. I'm going to factor, or I'm going to multiply by -1, either way. So I'll factor. Okay, and so now they are alike, and I can cancel, reduce to 1. And so now in the numerator I have a 1 divided by a -1, which means that I have an overall answer of -1. Okay. All right, tomorrow in class we'll go through how to check these on the checking on the calculator and suggesting equality. All right, have a great night.